Convex holes are a great way of visualizing data. So in this tutorial, you're going to be able to learn how to create them in Python as well as how to use them in analysis. Hey everybody, welcome back to the channel. My name is McKay. If you're new around here, I'm a current Master's of Data Analytics student, and today we're going to be covering convex holes in Python. So these maps are actually known as territory maps, and they're actually really cool to use, and if you've seen them on Twitter or anywhere, you've probably seen the cool things that people are doing with them right now, which is just really outstanding. They are able to capture really the distance that a player or a team is covering during a game based on certain actions, whether that be passing, whether that be defensive, whether that be passes into the penalty box. It's a really great way of visualizing the data. Some people might confuse these as well with heat maps. Heat maps show kind of the general trend of where a player was at based on their actions, based on the different things that they were doing. And convex holes really just show kind of the largest area that a player covered with all their actions. It really just depends with these maps what you're trying to show and kind of the ways that you're going to filter it down. For example, if you're going to be showing defensive actions, you'll just want to filter it by defensive actions. If you're going to show their passing territory, you'll filter it by their passing territory, etc., etc. And before we jump into the video, I'd like to just basically shout out FC Python. A lot of these ideas and a lot of kind of the coding inspiration came from FC Python. They have a great written tutorial on convex holes, so be sure to go check that out. I'll link it in the description, their Twitter as well as the website page, where you can, if you'd prefer reading, go look at that as well. And it's kind of basically going to be close to the same thing. And so with that being said, let's go ahead and jump into the tutorial. Okay, so getting started with the tutorial, we're going to be doing it in Jupyter Notebooks like always. And another thing that we're going to need to make sure we do is go to my GitHub, link is in the description, and you can download the file as well as I'll upload this tutorial and you'll be able to download that so you can follow along and kind of see what I'm doing. And as well, I recommend that when you do this, you don't just watch, but you also follow along. It helps be able to kind of remember the things that I'm doing and why I'm doing them. The first thing that we're going to do is we are going to need to import all the libraries that we're going to need. So we're just going to start off by importing matplotlib. So we'll say import matplotlib.pyplot as plt. Then we're going to import pandas as pd, and then numpy as np. And then as well, we're going to import matplotlib, just base matplotlib library, not pyplot. So we'll just say import matplotlib as mpl. And then as well, we're going to be using stats bombs pitch from MPL soccer. So we'll say from MPL soccer.pitch import pitch. And if you don't know what that is, make sure that you go watch my other video on how to create a soccer pitch in Python. MPL Soccer's library is fantastic for doing this, so we don't have to sit and draw everything out by ourselves. And then for the actual creating of the convex hole, what we're going to need is we're going to need two libraries. We're going to need, and they're both from SciPy. I don't even know if that's how you say it, but basically SciPy has some great modules and great things inside of the library that are going to help us. So we're going to say from scipy.spatial, we need to import convex hole just like that. Make sure the C and the H are capitalized on that. And then as well, we're going to say from scipy import stats. And we're going to be using both of those to kind of, the stats is going to help us filter our data a little bit better. And then the convex hole is going to help us actually create the convex hole. So just run that cell, and then the next thing that we need to do, make sure you spell everything correctly. God. Anyways, the next thing that you need to do is we need to create our data frame and just read in our CSV. So we're going to say data frame equals pd.read_CSV. And on this, the CSV I'm using is called convex tutorial.csv. And this CSV just contains the game, all of Barcelona's actions in the game that they played against Elche in January of 2021. Not sure of the exact date, but Barcelona ended up winning 2-0. So that's what this data is from. And then the next thing that we need to do is actually we want to fill all of our empty values with 0 if we have any. So we're just going to say df equals df.fillNA. and then if we put a 0, that'll fill all of our null values, everything that's missing, with a 0, so that we can run for loops over it eventually. And then the next thing that we need to do is we need to make sure that our x and y coordinates are set up to work with our statsbomb pitch. So statsbomb, like I've said before, it is a 120 on the x-axis by an 80 on the y-axis. So we're just going to say df y, not uy, y is equal to 0.8 times df y. So that multiplies all of our y values by 0.8, so it fits the 80 value. And then as well, we want to say df x equals 1.2 times df x. So what that's going to do is that's going to make sure that our x and y coordinates are scaled according to the actual pitch so that we aren't plotting stuff in the wrong spot. So I'll run that and just make sure that it worked. And the next thing that we need to do is we just want to create a data frame for, we don't need to necessarily do this for this data set because it's just Barcelona, but essentially what you're going to want to be doing is you're going to want to make sure that you have your data frame for only the team that you're looking at. I mean, you could plot everybody, but it would just be really a lot of stuff going on. So we'll say df equals df, and this is how we filter for just Barcelona. So we say df equals our data frame, and then we want to make sure we're grabbing the team ID column, and we want to set that equal to, so with the double equal sign, and Barcelona's team ID is 65. So we'll run that, and now we can look at our data frame and kind of see what's going on. So basically we have this event ID which is for the database, and then we have this minute right here with the minute, second, team ID, 65 is Barcelona. Here's all of our X and Y. Here's the player ID, and then here's our basically what type of event it was, what type of action. So start of the game, then we have like a pass, interception, etc. And then this is just the value. So 1 is equal to pass, and then like 50 is dispossessed, 8 interception. So that's how we kind of look at that. And then the next thing that we're going to want to do is our player ID. As we can see, it's in float values. This isn't like a necessary thing, but it's something that I like to do. I like to make these just not have the decimal after them, make them actual integer values. So we're going to say data frame, and we're going to run player ID. So that column is what we're going to be changing, and then we're going to say data frame and just basically type the same thing again. We're going to put a dot as type, so this changes the type, and we just put int in there, and that will change it. And so the next thing that we're going to want to do to make sure that this is all the prep that we're needing to do, and what we need to do is we just want to find all the unique player IDs in this column. So we want to get a list of the unique ones because it's going to help us be able to, one, filter for if we just want to make a single player, and then as well if we want to make the whole team, we'll be able to loop over the different players. So what we're going to do now is we're going to make a list called players, and we're going to set that equal to our data frame player ID, so that column, and we just type in dot unique, which gets all the unique values. I mean, we can run that, and then we can look at the actual list. And so it comes out in as array, and this is just all the player IDs. So we have 0, 5, 28, 4, 23, 7. So this is just all the player numbers, essentially. And then we're going to want to find the starters as well, and most likely the starters are just going to be the first 11 in this list of players. I mean, unless somebody got subbed off before like the 5th minute for some reason, which rarely happens, and as you can see here, since we filled everything with 0, we don't want to grab this when we're getting our starters list. We're going to want to start with number 5 and go all the way up until 16. Pedri was the one that started this. He started. So 16 is the last one. We just want these right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to create these starters, and we're just going to say starters, starters equals, and we're going to take it from our player list. So we're going to say players from 1 from our first location, which is technically our second in list indexing. Then we're going to put a colon up until our 12th, because we want to take 1 up until 12, but we don't want to take 12. It's a little bit confusing if you don't really know about list indexing. I would recommend going and checking that out as well. Just Google search it, you'll find a lot of things about it. So we'll do that, and now we can look at our actual starters list. So this list right here is just all the people who started. I mean, you can add everybody if you want, but it just gets to be a lot of people. Like for example, if a team uses all 5 substitutions, it's going to be a lot going on. So we're just going to look at the starters. And then as well, if you want to, you can sort that. I'm not going to do that in this video though. So now the fun part is we're actually going to start plotting. So we're just going to do a single player first. And I'll just run a couple cells so we can get this up higher. And I do this basically just by typing in fig ax equals plt.subplots. And then we want to set our fig size as well. So we'll say fig size equals, and then we'll do, I usually do about 13 and 8.5 around there. Not minus, we need to do equals. So we'll do that. And then as well, we're going to set the color, so like of the actual like grid of the actual pitch. So we're just going to say fig.set_face color. So this is just changing the color of everything. And the one that I've been using recently is like a smoke gray. That's 3B, 3B, 38. So it's just kind of like that smoke gray color. It's a good looking aesthetic for everything. And then as well, we're going to set, this is just something else that we need to do, is we're going to say ax.patch.set face color just to that same thing. So our whole image is the same color rather than, and I'll just copy it from in there and then put it in. So this makes it so it's all the same color and there's no white or anything. And then the pitch, what I've done in the past is just used MPL Soccer. So we'll go there and we'll go MPL Soccer and we'll head over to the examples. I've done this like a million times already, but this is the one that I like using right here, just called pitch. We need to copy all of this right here. And then we'll just paste that in, and then I'm going to change the pitch color to this right here. Kind of a lot going on just to prep, but make sure that the orientation is horizontal, and then you can really have it however you want. And then to get the pitch to show up, we just need to say pitch.draw, and then we need to set our AX equal to this AX right here. So AX equals AX. And then as well with the stats bomb pitch, the stats bomb orientation, they have a y-axis from 0 to 80. We actually need to invert it. So we're going to say plt.gca. It's just how we invert it. And then if you say .invert underscore y-axis, then that kind of inverts it. And we can run that. And so now we can see this is our pitch and this is what it's going to look like. All right, so now that we have our pitch, really the only thing that we need to do is we just need to create a new data frame for the player we want, and then we're only going to be looking at passes. And then as well, we're going to do something to filter the passes a little bit, and then we'll create the actual hole. It's not super complicated. It's quite easy. So we'll just say, since we already created a data frame, we'll create a new one called data frame 1, and we'll set that equal to our original data frame. And then we will get the player ID. We're going to look at Frankie de Jong right here. So if we set our player ID equal to 21, just like this, this is kind of the way that we get and we filter a data frame by a specific column and a specific value. And then as well, since we want to be looking at passes, we're going to just set that data frame again equal to this time we're going to use data frame 1 since we already created it and we're just looking at Frankie de Jong passes. So data frame 1 and then data frame 1 again. And then the column that we need up here is this type value. We're just going to look at this one right here, type value. So you can copy that and just kind of paste it on the inside of the string just so you get it typed correctly. And then we need to set that with the double equal sign equal to 1, because as we can see, 1 is equal to our pass value. You could use the type display name and just set it equal to pass. I just find that typing 1 is quicker than typing pass. I guess if I'm, not for this tutorial, but just when I'm doing these outside of the tutorial. So if you wanted to look at what the new data frame looks like, we can come down here and just type in data frame 1. Oh, I got to run this cell first. So we run that, and then we can look at what this looks like. So this is all of Frankie de Jong's passes that he attempted in the game. And as you can see, there's 73 rows. Before there was 960, so we know we filtered it down. And as well, we have all of our X and Y values, so we're on the right track. And another thing that I like to do is I like to filter these to exclude outlying points. So for example, if Frankie de Jong, all of his passes are over here, but then for some reason he had one that was clear up in the corner, it would make the convex hole all the way around, so it would look huge when really it was just one up there, which doesn't really truly represent his, like the distance he covered and like the space he covered. So we're going to use, this is why we imported the stats module in library right here. And we're just going to basically on that data frame, we're going to set it equal to, and we need to put df1, and we're going to call numpy. So in parentheses, we put np.absolute. So we want to get the absolute values of, and then we're going to put stats.zscore. And then we have to put after that df1 and then call in our columns X and Y inside of these two different things. So make sure you have that in strings. Okay, so after the second one right here, we're going to put less than 2. So essentially what this is going to do is it's going to filter out all of the z-scores for the X and Y values that were, it's basically going to eliminate everything that's over 2 standard deviations away, which normally you do 3 because 3 is going to capture more of the data, but 2 I feel like does better in this scenario. We just want 2 standard deviations away. We're not really looking for more than 2. You can even filter it down smaller depending on what you're trying to look at and everything. It's a good way to filter out the data and kind of help us make sure that we're eliminating outliers. So now what we're going to do is we're just going to create a list, basically an array of all of our X and Y coordinate groups. And so what we're going to do is we'll just create a new list called points, and we will set that equal to our data frame 1. And on the inside of that, we need 2 brackets, and we say X and then comma and then Y, and then we need to put dot values after that, and that's going to help us. Points is just going to be a list of, or an array of all of our different X and Y coordinates, and it's just going to put them all together combined so that we can run through that. And then after that we need to create the actual convex hole. So we're just going to say hole, we'll set it equal to the object hole, and this is where we're going to call in the convex hole that we imported, and we're going to set that equal to data frame, and then same thing again to data frame 1, and then set that equal to our X and Y. So X, comma, Y in strings, not YF. And then since we have everything really set up, we can look and see what Frankie de Jong's kind of his passes would look like. We can just use them as scatter plots, and we can say plt.scatter, and you just do df1.x, comma, df1.y. We can plot that, and so these are all of his passes. So what we're going to do now is the whole package is going to basically plot around the most outside values of these plots essentially. So we're going to do that using a for loop. And we're just going to say for I in whole.simplices we just are going to do plt.plot, and it's going to plot a white line in between them. It'll say plt.plot, and then we'll say points, so we're getting from our points array that we created, and we'll say I, comma 0, and then after that for our y, we'll say points, and then I, comma 1, in brackets, I, comma 1, and then we'll just color it white, and then if we want to fill it, we just say plt.fill, and we do points, and inside of here we do whole.vertices, comma 0, and then on the outside of that we do points, whole.vertices, comma 1. We can set that color equal to white as well. And then we're going to use the alpha argument, which basically just makes it more transparent. We'll say 0.01. So we'll run that and check out how that looks. I probably need to spell right vertices. And there we go. So now this is Frankie de Jong's convex hull. We'd obviously add a title, add different things to this graph, but that is essentially how you're going to create it just for one player. Now if we're looking at 2 players, it's basically all we're going to do is we're just going to run a for loop over our data frame, and this is just going to help us run through each player essentially and just plot it on the same thing. So what we're going to do is we're just going to copy all of this up here since we're going to need that, and we're basically just going to copy and paste stuff so we can look at everything. So we created a new pitch, as we can see, and then what we need to do is we just need to create a for loop, and we're going to say for player in starters, so in our starter list, and we need to create a new data frame, so we're going to say df2 equals, and we want to create it from actually our original data frame that we had. We don't want to create it from our new data frame that we did with Frankie de Jong, so we need to grab this data frame, df, right here. So we'll say df, and then df player ID, and we want to set that equal to our player right here. We don't want to set it equal to a certain number. We want to make sure that we're using the iterator. So this could be I, this could be X, this could be whatever, but we named it player. We need to make sure that we're filtering this data frame as well. So just for the sake of not copying or for having to type everything, we can just copy this right here. So this type value, and then change the 1s to 2s. What this is going to do is this is going to go through each player in our starters list, and it's going to create a new data frame every time it runs called df2, and it's going to filter that data frame for only passes. And then we also as well need to make sure that we're filtering it down with our z-score method, so we'll just copy and paste that again. Make sure we're getting rid of outliers and making sure that we're typing it correctly, so changing all the 1s to 2s. And then as well, what we're going to do is we need to create the points list. So we'll say points equals df2, and then on the inside just x and y inside of the double brackets, and then we'll put dot values. And then the next thing that we're going to do is we're going to use 2 try and except statements, which basically is just going to say it's going to create the whole, and then if an error comes up, like if there's not enough points for the actual whole, it's just going to pass on that player. Like for example, if a player only had 2 passes the whole game, it would basically just skip over that player so we don't get an error and that the whole thing can run. So what we need to do is we need to type try, and we're going to say whole equals just the same thing that we did up here. So this convex whole, we'll just copy that. I'm all for not having to retype everything and just do df2. And then underneath that we need to put the except, not expect, I can't spell, except. And by doing this essentially, if we type in pass right here, this means that if an error comes up on this whole creating the convex whole, it's just going to pass so that the whole thing will run. And then The next thing we need to do is we need to just do another try and accept. So we'll say try. And so if we've gotten this far, we need to essentially just do this again. We're just going to put in this right here. Say Command C. And just make sure that your indentations are correct. So this is just tabbed once from the for and then tabbed once from the try. And then after that, we just need to put another accept. So this is just making sure that we're covering all of our errors, all of our ground, so the whole thing's going to run. So that really is all we need to do. It was super simple once we've gotten everything set up. It's just one for loop, basically to make sure that we're going over all the players. So we'll run it, and that is what it looks like right now. As you can tell, it does not look very good like this, and on this instance, I would actually recommend maybe just bumping this down to like 1, seeing if that helps. Didn't really help. I mean, you can even bump it down to like 0.5. Depends on how much data you want to eliminate. But, I mean, you can kind of see that we've eliminated a little bit more there. I mean, if you're wanting to make all these colors different, then you'd have to create essentially just a list of hex values or RGB values. And for the color, you wouldn't put a firm color. You'd have to put in, basically you'd have to loop over that list as well. You could just plug it into here just so that when you're actually looping over that list, that all the different colors are going to be a different player. It's not super complicated. It's just not something I'm going to cover in this tutorial. If you have questions about it though, you can reach out to me on Twitter and I will definitely send you over some code that can help you do it. So that's it for this video, guys. Thanks for watching so much. And as well, if you have any questions, be sure to reach out to me on Twitter. That's the best way to get a hold of me. As well, if you haven't already, be sure to hit the subscribe button, the like button, if this tutorial helped you at all. And leave a comment what other type of tutorials you would like to see in the future, and I'll definitely be sure to get around to those. So once again, thank you, and I'll see you in the next video.